I want to draw your attention to a common error, and I've actually seen it at least 3 times over the last couple of days when I've been sitting working with students. So we have a law of exponents that says if you have things that are multiplied and they're raised to a power, then you can apply that across. So you would have a to the mn, b to the mn. Now that's okay to do. But there's no such rule for adding or subtracting and applying the exponent across a sum or difference. There's no rule for that. The only thing that we can do is follow the order of operations and see where that takes us. So let me look at an example here. So let's say we have a to the minus 1 plus b to the minus 1 squared. There's absolutely no rule that allows you to apply an exponent across a sum or difference. So you cannot do this. You cannot say that, oh, that's a to the minus 2 plus b to the minus 2. Definitely not true. And what I'm going to do is use some numbers to show you that it's not true. So I'm going to let a equal 4, and I'm going to let b equal 3. And I'm going to work both sides, and you're going to see that we are not going to get the same value. So on the left side, I'm going to have 4 to the minus 1 plus 3 to the minus 1 squared, which is not going to be equal to 4 to the minus 2 plus 3 to the minus 2. Following the order of operations, I have to do the work in these brackets. So that's going to be 1/4 plus 1/3 squared. And inside the bracket, I get a common denominator of 12. And then I'm going to have 3 plus 4, which I'll square. So that's going to be 7/12 squared, which is 49 over 144. So now let's continue with the other side. So this is going to be 1 over 16 plus 1 over 9. The common denominator for 9 and 16 is 144. Oh, that kind of looks promising. Then I'm going to have 9 plus 16, which is 25 over 144, which is not equal to 49 over 144. So you can see that applying that across does not give you the same answer as following the order of operations. The one on the left is the one that's correct. The one on the right is following a rule that doesn't exist. Let's take another look. Let's say we had x squared plus 1 squared. Students are going to do this one correctly. You're going to say, oh, I'm going to fill that out. I'll get x to the 4 plus x squared, which is 2x squared plus 1. You're going to do that one correctly. Change it to something like this. I see people apply that cube across that sum all the time. But you can't do that. The only thing that that's equivalent to is x squared plus 1 times x squared plus 1 times x squared plus 1. It is not equivalent to x to the 6 plus 1. You cannot apply that exponent across the sum. Another common case of it is when you see something, especially with the -1 exponent or the negative exponents. Let's say I had x plus y squared. People are going to do that one right. They're going to say that's x plus y times x plus y, which is x squared plus 2xy plus y squared. Usually people do that one okay. But as soon as I put the negative, it messes people up for some reason. You cannot apply that exponent. You cannot say that's x to the minus 2 plus y to the minus 2. Fill numbers in. Check it out. The only thing that that is equivalent to is 1 over x plus y squared. Now if you want to FOIL at the bottom of that, you can. You could say it's 1 over x squared plus 2xy plus y squared. I myself would leave it like that, but you could FOIL it out. Let's just take that and fill in some numbers, and I'll just show you that it's not correct the other way. So again, x plus y to the minus 2. It's definitely not going to be equal to this. So let's let x equal 5, and we'll let y equal 3. So I'll have 5 plus 3 to the minus 2, which is not going to be equal to 5 to the minus 2 plus 3 to the minus 2. So that's 8 to the minus 2. That's going to be 1 over 5 squared, so 1 over 25 plus 1 over 3 squared, 1/9. So that's 1 over 8 squared, which is 64. And I'm going to add those with my calculator. 1 ABC 25 plus 1 ABC 9, 34 over 225. Definitely not the same thing. Do not apply exponents across a sum or a difference. Either follow the order of operation or don't do anything.